Okay, welcome back. So hopefully you've got this thing working. You've got your Uno plugged in. You've loaded this example piece of code. You've played with it. You've changed the time rate. Everything is working great. Okay. Well, now it's time to actually dig in a little bit and get nitty gritty with some of what actually happened. And to do that, I think we have to sort of understand what this is, what this Uno actually is, and what all these pins are and these numbers and what does it all mean. Okay? And then once we kind of have a handle on that basic understanding, it'll make a lot more sense when we talk about the code, because what did I do when I set pin mode, and what did I actually do when I do a digital write? Okay? So I think we have to understand a little bit about these pins to understand how these things all link together. So I'm going to do this the easy way. I'm just going to go to Google and put in there the Uno pinout. And from here I'll jump to images, and let's just grab this very first one. Let's just click on it, and I'm going to make this full screen so we can actually take a good look at it. Okay, so here's a diagram of the Uno, and you can see that each of these pins, these sockets, have a number of different potential functions. Okay, we're going to deal with the simplest things first. We simply want to be able to turn on and off these pins right here. So this group labeled from 0 to 13, these are pretty much just digital pins. It says so right here. There's digital and there's pulse width modulation. Obviously we'll get into the PWM much later, but right now we want to deal with digital. Digital is just 1 and 0. It's on and off. Okay? So we're going to be working with these pins and doing nothing more than turning them on and off at different rates, at least initially. This other side, though, has some other very cool and unique pins. These labeled A0 to A5. These pins are digital as well as analog. Okay? And analog means that these pins can actually measure some variance, right? It measures voltage ultimately. It can take a voltage in and it can tell you how many volts it is with a very narrow range. Much like you can look at a screen or a light or a color and you can see various shades of gray or various shades of color, these analog pins can see various voltages, again, within a range. And that allows it to have some sort of variable sense. These digital pins can only input on and off. That's it. Okay, the and or output on and off. They can't see changes or variance in those values. So if we go back to our device here, let's go to our code first. What actually happened in this code is the very first thing we did is we set pin 13, okay, which, by the way, let's see if it shows it on here, has the LED. This is the designation for the LED. That onboard LED light is hooked up to pin 13. So what we do is we give a name, we assign a name. I could have called it anything I want. LED, light emitting diode, is a logical name. So the name LED is used to designate this pin, pin 13, which has this LED on it. Okay? We go to setup, and then we have to set the mode of that pin, because remember, this is digital. It can be both input, and it can see or receive an on and off, or it can be output, and it can send an on or off. In this case, we're going to send an on or off. We're going to turn it on and off. We're going to light the light, and we're going to light the light which is on pin 13. And then down here, again, these pins, all right, switching to our other diagram, these pins here, okay, these are digital pins. So we are going to digital write to what? LED. What's LED? Well, LED is pin 13, and we're going to set it high. In other words, we're going to turn it on. We could have used the designation of just a 1 here if we wanted to. It'll work fine, but we're going to use high, and then we're going to go on for how long? A half a second, 500 milliseconds, and then we're going to set that pin low. And this is just going to go over and over and over again, running through that sequence. Now, later on in this course, we're going to do something called analog write. Okay, we're going to be able to send out a value, and it won't be a value of just on or off. It could be. I could set an analog value of just turning it on and turning it off. But we're going to be able to set that value to some range, okay, that we're going to be able to deal with. And we'll get into that at a later time. But hopefully this is a little bit of realization. Ultimately, we're going to be controlling these pins, okay, utilizing this code, and then we're going to be uploading this code into this processor. So if I come back over here, this is going to be the processor core. It's got memory in it. It's got all these ports. It has a number of different clocks and various other built-in functions that allow it to operate. We're going to be sending our code via the USB port into this device, into its memory, and then it's going to run that program and make these pins respond. I should point out there are other pins apart from the communication pins. Of course, over here you can see a number of pins that are labeled for voltage and ground. And there's a reset pin. For example, if I hook a button to, I can reset the processor. It's essentially the same as this button right here. And then there's some communication pins down here we're going to be able to utilize at a later time, so be able to control remote devices. But for the bulk of this, we're going to be dealing with these digital pins and these analog pins. And as we build circuits, we'll be taking advantage of these voltages and grounds and being able to bridge off of them into something called breadboards. So hopefully this was useful, and I will see you again very soon.